We are here to not only help you build your projects, but really our number one concern is your safety, to make sure that you're using the equipment properly. Whether you're doing this as a refresher or you're going for recertification, if you're not sure about how to use any piece of equipment, any tool, please just ask us. We're here and we're willing to help. Okay, as soon as you walk into the shop, you are now adhering to shop rules. Rule number 1 is you have to have your proper shoes and safety glasses. They go on immediately, they're right hanging on the wall. I also choose to use earplugs. There's no horseplay. There's no talking on the phone. We are totally focused on what we're doing and paying attention to the equipment when we're using them. And any questions, again, just ask any of us. Before operating any piece of equipment, equipment moves, spindles turn. Our long hair is tied up, our sleeves are rolled up or tied tight, shirts tucked in, no big necklaces hanging out. Safety is number one concern. Next thing you do when you come into the shop, you come over and you scan your student ID card. Swipe your card. It will print out a label. It will only print out a label if you're certified and if your certification is current. Your label has to be placed somewhere on your body that is visible to us. That way when we scan the room, we see everybody's labels and we know that everyone's certified that's operating equipment. If your certification is not current, you have to come see us and you'll sign up for a recertification class. Recertification requires you watch a video, a safety video. We go over the shop rules and you take a test. Okay, here we are with the belt sander. The belt sander, we are going to deburr the part. This particular part was saw cut. There are sharp edges on it. I can feel them with my fingernail. My fingernail is catching. For safe handling, and so the part sits properly in a holding device, we want to get rid of the burrs. So we're going to come over to the belt sander. We are going to hold the part at approximately a 45-degree angle, get a good firm grip on it, and because the belt is not as wide as the part, we're going to have to travel the part back and forth to take the burr off. I am staying totally focused. Burr is gone. Burr is gone. Shut the machine off. And then we're done. Okay, here we are at the drill press. Here is our part. It is already deburred. There's no burrs on it. Another reason why we want to make sure the part is deburred is so that the part sits properly in the work holding device. In this case, we're using a vise. If there is a burr on it, exaggerated, the part is going to sit crooked, and we're not going to be drilling our hole square to the top surface. Okay? The other thing we have to pay attention to is that the sides of the part are parallel, so that when it sits in the vise, it's being squeezed properly. We are making sure that the vise is clear and clean of chips and that the table is clear of chips. Again, if there's chips, if it's sitting on chips, the part is going to sit crooked. Okay, we put our part in the vise and we make it tight, tight. I have put on here, I scribed out some crosshairs. That's our point where we need to drill our hole. The first thing we're going to do is we're going to drill we're going to spot the hole. It creates a little location so that this drill bit doesn't wander. It follows the spot. We're using a center drill right now. We're loading the center drill into the chuck, tightening it with the chuck key. Totally focused. Not paying attention to anything else. Okay, I want to line this point of the center drill up with the crosshairs. So I'm looking in two directions. I'm going to look in this direction, make sure I'm lined up that way, and I'm going to look in this direction, make sure I'm lined up this way. Once I feel I'm in the right spot, I'm going to center drill the hole. I wait till the spindle stops before I clear any chips away. When loading the drill bit into the chuck, the three jaws that come out of the chuck, I want to make sure that the drill bit is in the center of the three jaws, that it's not in between two of them. If that's the case, the drill bit is going to wobble around. So I'm looking, making sure that the drill bit is centered to the three jaws. And I tighten the chuck. We've spotted the hole already, so the drill bit is going to start in the proper location. It's not going to wander off. Turn the spindle on. I want to get a firm grip in my left hand, yet allowing it to center itself to the hole. Once it's there, I'm going to just commit and go. I am going to peck drill, going to go approximately 1/8 down at a time. That way the chip breaks and I allow coolant to get back in the hole. We're using coolant. It cools, lubricates, and flushes the chips away. So I am peck drilling. Come all the way out, do another spritz of coolant. When you feel the drill bit starting to break through, you don't peck anymore. You continue all the way through, slow and steady. That's it. Good firm grip as you're breaking through so the part stays down on the table. Spindle stops before you clear anything away. When you're all done, you take the brush, clean everything up. For the next person. Okay, now we're on the bandsaw. Again, totally focused. Any other distraction, someone walks in, starts talking to you, we don't pay attention, we're focused here, say give me a minute, wait till I'm done. We're focused on here. Okay. The safety guide, we lower it. We have to unlock it, we lower it just to above the part. We want to minimize the amount of blade that's exposed. Lift, relock it. I'm going to cut along this line. I have everything set. I have a bandsaw pusher. This allows me, when I start to get close to break through, that I don't have my fingers there when I'm breaking through, that I push with this right where the location of where I'm cutting, and I push, and it's okay if the bandsaw cuts into this. This is just a sacrificial piece of wood. Okay, I have it lined up. The bandsaw will make slight curve cuts, but not so extreme. You can't really force the blade. Okay, everything's clear, table's clean, I'm all set to go. Power on. I want to keep my fingers a couple inches away. I'm going to start cutting. And I walk my fingers back. Okay, I'm getting close. I'm going to use the bandsaw pusher, and I'm pushing right here. Slow and steady. I'm about to break through. Cut into the thing. I wait till the saw stops before I move any pieces away. I am not reaching to grab a piece. As the blade is turning, someone bumps into me. Not a good thing. So I wait till the bandsaw blade stops before I move any pieces away. Any little scrap piece, again, shut it off, wait till it stops. cutting a round piece, there's no way for us to grip it. It's going to rotate. We need to use a vise. The way to use the vise on a round piece, turn it upside down so it's held flat up against the table, and then tighten it. Okay? Now this is a small piece. I have to raise my guide, retighten it, and I'm going to use the bandsaw pusher. Again, focused here. Everything's all set. Press the button on. Shut it off, wait till the blade stops. I'm done. Clean it off. On to the next. Okay, here we are on the miter saw. First of all, the piece that you're working with has to be big enough for you to be able to hold firmly. It can't be a small, tiny piece. Your hand's going to be too close to the blade. Totally focused right on here. We put the saw up against the fence. Line up our cut line to the blade. Make sure we look okay. We have a good firm grip. We're holding down up against the face and up against the fence in the back. Totally focused. It's going to be loud. Here we go. We're going to cut through the piece, release the trigger, wait till the blade stops, then bring it up. Slow and steady. That's it with that.
Welcome, students, to our Florida Tech YouTube video presentation. This is our vertical milling machine. What I'm going to do is refresh how we approach the machine when we're starting to work, because there's been some problems in terms of how to put the tools in, take the tools out, and various other elements. So we have a part, we need to mill it square. So the first thing we want to do is set the machine up to mill this surface here. So we see we have a drill chuck in here. This brings up an important point, is we do not put drill bits into collets. We only put drill bits into the drill chucks. So if you're going to use the milling machine to drill holes, we need to put a drill chuck into the machine. But right now we want to put a milling cutter into the machine, so we need to take our drill chuck out. So we take our 3/4 inch wrench, we put it up on top of the drawbar, because we have to unscrew our drawbar to release the drill chuck. We put on the brake, release the drawbar about a half a turn only. Then often you can just take and tap the drawbar with a wrench and it'll come out. Other times it won't come out and you have to use a nice brass hammer. This time it came out quite easily. You unscrew the drawbar and take the drill chuck out. So let me show you what the drawbar is. This is actually the drawbar that runs down through the spindle, and this is actually a collet. So what we're doing is we're putting our cutter, whatever type of cutter or drill chuck, into the collet, inserting the drawbar, and then when this tightens, it pulls up against the taper here, which locks the cutter or the drill chuck into the machine. So when we go to take it out, we unscrew the drawbar just a little bit and then tap it. One thing that's been happening, and we lost 3 drawbars last year in 1 week, is the students will unscrew the drawbar and completely from the collet, then take the brass hammer and pound it. What happens if that happens is it rolls the first threads of the drawbar and pretty much ruins it. So the correct way is to unscrew only a half a turn. If you have to whack it with a brass hammer, you can give it a really good pop, or 2 or 3 or whatever it takes to release the taper onto the collet, and you do not injure the drawbar because there's enough threads engaged that it won't get mutilated. So now we want to put our end mill into the machine because we're going to mill the corner of the plate. We insert like this, reach up here to the drawbar, and screw it down into the collet. At this point, we take then our wrench again, put our hand on the brake, wrench at the top of the drawbar, and we tighten it. And all we have to do is just firm it up. Twice, students have tightened it so tight that I had to go get a pipe and put it on top of here and push while he held the brake to unscrew it. Doesn't need to be that tight. The next thing we do, we need to know how to turn the machine on. This switch has a high and a low. Depending upon which you go to, high or low, is depending upon the rotation of the cutter. So I'm going to switch it one way. Notice that the cutter goes in the correct direction, which is a clockwise direction as you're looking down. The switch has two positions like I mentioned. If I turn it into a low, it's going to turn backwards. This is part of our machine shop training, and it's called awareness. This is a real Zen type environment. Zen being that if your thoughts are going 100 miles an hour and you're thinking about this and that and the other, then those block your attention. We have to shift our attention from thoughts to being here, present, now. Zen. So, first thing you do when you turn on a machine is you watch which way it cuts. If it's turning counterclockwise, we got a problem. The problem is it won't cut. It destroys the part, destroys the cutter. So that's $30 down the drain. And this happens quite often. The other thing is, when we do use our cutter, we use our cutting fluid. It's very much like, it's a soluble oil, very much like dish soap. That keeps the aluminum or steel from gumming up and ruining the tool. Okay, one of the things that happens when a student turns it on backwards is he says, well, this is a stupid machine. It's got 2 positions. It's got a high and a low. Why doesn't it turn on just like my fan? It only goes on in the right directions. Well, there's a reason for that, and it's not a stupid machine. It has what's called a back gear. This is the back gear. What happens is it's in high range now. If you push this knob in, move it towards the back, then you turn the machine on to low, it's going to turn in the correct clockwise position, but much slower. So we have a back gear for turning really slow, drilling really big holes, cutting really hard material. Then we have the forward position, high. Notice that when I move this over here, it didn't go all the way. You must grab the spindle, give it a shake, and then it will pop into your high range. If you don't do that and turn the machine on, it'll make the loudest, ugliest noise you ever heard in your life and be very embarrassing. So, okay. the right direction. It's still maybe going too fast. This machine is variable speed. So we turn it on. We can slow the speed down or speed it up with the variable speed knob. Speed is very important. That comes to another situation. Is we as students don't always know the correct speeds and feeds and whatever to use. So that's when you come up to me or Anthony or Bill and say, gee, I'm not really sure. We'll step in, we'll help you out. The last important point that I want to address is the difference in the way you can mill a part. If this cutter's turning clockwise and we come across this edge here, then that is conventional milling. So the part actually progresses into the edge of the cutter. That's the safe way to use these manual milling machines. If we go in the opposite direction, it's called climb milling. That's where the milling cutter is going also in this direction, but we're actually climbing on top of the edge. That's not safe on these machines. The reason why it's not safe is that the tables are very, very loose and they can shake. And then what will happen is as it climbs onto the part, it'll grab a hold of the machine and pull it into it. At that point, it can break your part, break the cutter, and cause some problems. The one last thing I want to mention is if you're milling in this direction, there is a lock, a table lock on this side that you can put on to keep the table from drifting as you're milling across it. If you're milling in this direction, you can use a table lock here for the X that'll prevent the table from moving this way. That's about it for the vertical milling machine. This is the engine lathe. This handle moves it back and forth this way. This handle moves it this way. One of the problems we have in the past is turning the machine on. This handle turns it on and it rotates in this direction. We can also pull it upward and it'll rotate in the opposite direction. This is the way we do not want it to be turned on. If we do this, and we've had students do this, it ruins their parts, it makes a mess. It's hard on the machine. The cutters are like this. They mount in the tool post, and the rotating part comes down against the cutter, so it needs to rotate in the correct direction. I've labeled this tool post sharp to be for the sharp machine. You put it in the tool post, clamp it down, and the reason why it says sharp and it's labeled for this machine is the tool is right at the center line of the part. So the tools, whatever tools you use, need to be set at the center line of the part. This is a form tool. Does the same thing, puts a nice 45-degree chamfer on your part. This tool is a normal turning tool. It will face off and also turn your outside diameter. Provides two separate functions. One of the things that I've installed in this shop 2 summers ago is a travel indicator. What we'll use the travel indicator for is so we can bump up against our face. This is the face of the part. We can zero our travel indicator. And then we say we want to come back 500 thousandths and turn a shoulder here. So we can take our travel indicator and go 1, 2, 3, 4, and 500 thousandths. That's where we want the machine to stop when we made a cut. So we can readjust our travel indicator to not tell us a dimension, but to tell us where to stop. And this is very unique. This is a unique way of doing this that works quite well. So we take it to where it only makes less than 1 revolution, and we zero it. So as the machine is progressing across the part, turning our outside diameter, we can stop the travel at 80 or 90 thousandths and then hand feed it to 0, so that we're coming up against an established dimension.
Okay, I hope this has been a good learning experience for everybody. I hope that you've understood everything. Again, any questions, please come to any one of us and ask. We want this to be a safe environment and make sure that your projects are done the way you want them to be done, but that safety is the number one concern. Thank you and good luck.
It is estimated that 90% of workplace injuries could have been prevented if personnel had worn the correct personal protective equipment and used it properly. Unfortunately, the use of personal protective equipment, or PPE, is often not understood, resulting in accidents. PPE is a vital part of minimizing the risks of accidents. The risk of serious injury can be minimized if you understand the principles of PPE safety. You can't afford not to take PPE seriously. This program covers types of PPE including head, foot, hand and arm, eye and face, hearing, body, respiratory, and fall protection. We will also look at PPE risk control and maintenance and storage. Personal protective equipment, or PPE, comprises a range of clothing and equipment that is worn by personnel, contractors, or visitors to reduce their exposure to workplace hazards. Let's have a look at the range of PPE that is available to protect your health. Head injuries are classified as either closed or open. A closed head injury means you have received a hard blow to the head from striking an object. An open or penetrating head injury means you were hit with an object that broke the skull and/or entered the brain. Two common types of head injuries are concussion, the most common type of traumatic brain injury, and contusion, which is a bruise on the brain. Head injuries commonly result from impact from flying or falling objects, bumps and hard blows, and hair entanglement. Long hair should always be tied back or secured under headgear. In most cases, head protection will mean an industrial safety helmet. However, bump caps or an equivalent can be used in areas with particularly limited space. Head protection also includes hoods to prevent chemical splashes, hair nets and caps to keep hair from being entangled, hats to protect from the sun, and wet weather hats. Hard hats can include rims, visors, face shields, earmuffs, and may include neck and side protection. Headbands inside the helmet need to fit properly. The suspension system must be in good working order and may need to be replaced each year. Common types of foot injuries result from falling objects that may or may not be heavy, being run over by mobile plant, punctures from such items as nails and sharp metals, stubbing your toes, and contact with chemicals. Safety footwear includes safety boots with steel-capped toes and slip and puncture-resistant soles suitable for most general work, safety boots for use with chemicals such as steel-capped rubber or Wellington boots, safety boots suitable for working with electricity that are non-conductive and anti-static, shoe covers, spats, gaiters and leggings to protect against chemicals, welding sparks and other hazards, and shanks to go over the upper foot for additional protection. Safety footwear should be compulsory, except where there is a negligible risk of foot injury. Accidents can result from wearing poorly maintained safety footwear. For example, damaged soles can result in slips. Always make sure that your foot protection is in good condition, is kept clean and dry, and is free from defects. Common types of hand and arm injuries are abrasions, cuts and punctures, impact blows, chemical burns, electrical burns, thermal or heat burns resulting from contact with a flame, scalding from steam or hot or molten liquids, and contact with hot objects. Cold burns, such as frostbite, and skin infection and contamination. Gloves are the major form of PPE for hand and arm protection, and there are also protective sleeves or gauntlets, mitts, wrist cuffs, and armlets. Gloves can be made from materials such as latex, rubber, cotton, PVC, Viton, stainless steel mesh, Kevlar, and leather. There are a range of different types of gloves suitable for different tasks, such as gloves for working with chemicals and solvents, gloves that are cut resistant, gloves that are heat or cold resistant, gloves for work with high and low voltage electricity, gloves for working with vibrating machinery, disposable gloves, and any combination of these. When choosing gloves, always seek expert help. Advice should be sought, for example, from the manufacturer or distributor of a chemical agent or glove supplier. Always remember that if the inner surface of a glove becomes contaminated, it will not matter how much care, attention and expertise has gone into the selection process, exposure will occur. Gloves should always be dry and hole-free. If gloves are wet, they should be changed with a dry pair. Common causes of eye injuries are flying objects such as bits of metal and glass, tools, particles, chemicals, and harmful radiation. With just a little extra effort, it's easy to ensure that you and your co-workers won't suffer eye damage while on the job. Safety eyewear protection includes non-prescription and prescription safety spectacles, goggles, full visor face shields, welding helmets, and full-face respirators. A risk assessment should confirm the local hazards and the type of protective eyewear you should use. There are glass, plastic, and polycarbonate safety lenses. Glass lenses can be heavy due to minimum lens thickness requirements and therefore uncomfortable, low impact resistant, and are not always recommended as safety eye protection. Plastic lenses, including polycarbonate lenses, offer better impact resistance than glass, are lighter weight, can be coated for anti-fog and anti-scratch, and can be made in your corrective prescription. It is essential to check that the right level of protection is being used for each specific task. A full visor face shield provides protection for not just the eyes, but also the face and throat as well. Protective eyewear with a UV filter and tinting will protect your eyes from the sun's ultraviolet rays, which can cause a significant amount of eye damage. Contact lenses or prescription spectacles are not eye protective devices, and wearing them does not reduce the requirement for eye and face protection. If you wear prescription spectacles or contact lenses, you must ensure that all PPE is compatible and fits comfortably. Failure to wear hearing protection in noisy areas can result in hearing loss. Damage to your hearing is painless, may be permanent, and there is no cure. Hearing damage can be caused by very loud peak noise levels and exposure to general noise over longer periods of time. Effective safety hearing protection includes earplugs, including earbands and earmuffs, that are rated for specific noise levels. There are also earmuffs that are integrated with PPE, such as hard hats. When choosing ear protection, there are a number of factors to keep in mind. Your ear protection must be adequate for the level and frequency of sound in your work environment. Wearing ear protectors over long hair, spectacle frames or jewelry may reduce the effectiveness of the protection. When using earplugs, it is important to insert them correctly. Firstly, make sure your hands are clean. Dirty earplugs will cause ear infections. Roll the plug into a light cylindrical shape. Reach around the back of your head and gently pull back the outer part of your ear to straighten your ear canal. Insert the plug well into your ear canal with your other hand. Hold the plug in firmly and allow it time to expand and block the noise. Aim to get 3/4 of the length of the plug into the canal. Check your earplugs regularly to ensure they are not working loose. With earmuffs, note which way they are meant to be worn. Oval-shaped cups are meant to be worn so that the oval is vertical and not like this. Brush as much hair as possible away from the ears and make sure the ears fit right inside the cups and are not pressed against the head. Adjust the headband so it evenly takes the weight of the cups and holds them firmly in position. Run your fingers around the cushions to make sure there is a good seal against your head. Earmuffs can be used over earplugs for additional protection. Earplugs and earmuffs should be cleaned before and after a shift. Ear protection should not be shared with others, as this can lead to ear infections. Don't take hearing protection off in a noisy environment. Remember, a one-off peak noise or long-term exposure to general noise over 85 decibels may damage your hearing. Common types of body protection include safety overalls, non-porous full body suits, heavy and light-duty aprons, lab coats, hot and cold environment protection, high-visibility vests or jackets, and sunscreen to protect from UV radiation. Sleeves, knee pads and elbow pads are all available for extra protection when required. Overalls are required to protect people when engaged in dirty tasks and may be cotton or disposable. Aprons may be made from rubber, PVC or leather, and may be heavy or lightweight. They are required when extra body protection is needed, for example welding and handling chemicals. Appropriate clothing, for example insulation or water resistance, should be used when workers are exposed to cold or wet environments. Cooling vests or breathable fabric may be used to minimize heat stress when working in hot environments. When working outdoors or in the sun, water-resistant SPF 30+ sunscreen should be applied before a shift and reapplied every 2 hours. When working close to machinery, you must wear close-fitting and close-fastened garments that cannot get tangled in machinery. Body protection must be sized properly to prevent tripping, tearing, seam parting, or the restriction of movement. When conducting welding or flame cutting, or where there is a potential risk of fire, body protection should be fire resistant and/or flame retardant. Materials made with polyester blends should usually be avoided in these situations. Anti-static overalls may be required in some industries. Common examples of respiratory hazards include particulates and dusts, hazardous fumes and vapors, gases, and oxygen-deficient atmospheres. These hazards can be present from solvents, specialized paints, the joining and cutting of metals, welding fumes, dusts from wood or plaster, solder flux, hazardous chemicals, and confined spaces. Respiratory protective equipment, or RPE, includes air purifying respirators used to filter dust, fumes and gas, and air supplying respirators used in more hazardous situations. Air purifying respirators include particle filtering face masks, half masks, and full face masks. Different types of filters can be used with each type of mask depending on the hazards present. Respiratory equipment with eye protection may be required when working near smoke and noxious or poisonous particles and fumes, which can cause severe eye irritation. Air supplying respirators include airline systems, self-contained systems, and closed-circuit breathing apparatus. Before using an air-supplied or self-contained breathing apparatus, users must be trained and competent, physically fit, medically tested, and fit tested to wear this equipment. Falls from height remain one of the single biggest causes of disability, injury, and death at work. Assessments and control of risk are required even when the potential fall distance is less than 2 meters. Fall arrest equipment should be designed and used to reduce the possibility of injury if a worker falls. Fall arrest systems are used where workers are required to carry out jobs near an unprotected edge. Safety belts and harnesses, lanyards, safety lines, and safety attachments for ladder work can be used. Vertical and self-retracting anchorage lines can be used for work performed from bosun's chairs and ladders. Collective fall arrest systems include nets and airbags. Only people suitably trained and supervised should install and use fall arrest systems. PPE only protects the wearer. It does not remove the hazard. It is for this reason that PPE is considered the control measure of last resort. Elimination, substitution, isolation controls, engineering controls, and administrative controls should be put in place before personal protective equipment is utilized. But how do you know what type of PPE is suitable? Every time you do a task, you should assess the PPE requirements. The PPE must be appropriate for the risks and conditions where it is to be used, take into account the ergonomic requirements and state of health of the person wearing it, fit the wearer correctly if necessary after adjustments, either prevent or control the risk involved without increasing the overall risk, and be used in conjunction with other control measures. Material Safety Data Sheets, or MSDS, include information on the types of PPE that should be used for the safe handling of materials and substances. However, it is also important to check with suppliers and manufacturers to ensure the PPE is suitable for the task. Each type of PPE that you wear must be compatible, or the PPE could be ineffective. The extent of protection provided by PPE depends upon good fit and attention to detail. If PPE is used incorrectly or badly maintained, the wearer may receive no protection at all. Never let yourself be lulled into a false sense of security when wearing PPE. The hazard still exists. Even if you're not directly engaged in a potentially dangerous activity, you still need to wear PPE when people work in the vicinity. Never remove your PPE in designated areas. Even if it seems uncomfortable, it may save your life. Visitors are also required to wear PPE in designated areas. Ensure any PPE you use complies with the requirements of the Personal Protective Equipment Regulations and meets basic safety requirements. Using poorly maintained PPE can kill you. When maintaining and storing PPE, follow these rules. Clean PPE before and after use. Inspect PPE for damage before and after use. And replace PPE that is defective. PPE should not be left lying around where it can become contaminated. PPE should be suitably stored when it is not being used, for example in a dry, clean cupboard, or in the case of smaller items such as eye protection, in a box or case. Follow the manufacturer's maintenance schedule, including recommended replacement periods and shelf lives. If you use the correct PPE for the task, ensure it is worn correctly and kept clean and well maintained, then you will significantly reduce the risk of a workplace accident happening to you. An accident can occur when you least expect it. It is therefore vital that you wear your PPE whenever there is any risk or when signs require it. It could only take a split second and your life will change forever.
When was the last time that you had to use a fire extinguisher? For most of us, fire extinguishers are one of those things we like to have around but hope never to use. Hi, I'm Rachel Walla with Ally Safety, and in this video, we're going to cover some quick tips on fire extinguisher use. It's going to include the types of fire extinguishers out there, when to fight a fire and when to evacuate, and lastly, how to use a fire extinguisher. So without further ado, let's jump right into it. To know about how to fight fires, you first have to understand the fire triangle. For a fire to exist, there has to be 3 elements in place. Those elements are oxygen, heat, Fuel. Fire extinguishers are designed on the type of fuel that may be needed to be extinguished. Using the wrong type of extinguisher can actually just make a fire worse. Think, for example, of an oil fire being extinguished with a water extinguisher. Now, the oil is naturally going to float on top of the water, and the water will just encourage the fire to spread. So you have to know the type of fuel that you're going to need to extinguish to choose the right extinguisher. How fire extinguishers are designed is to remove just one side of the fire triangle. For example, a lot of the fire extinguishers are powder extinguishers. What they do is they suffocate the fire with powder, removing the oxygen. Or something like a water extinguisher will remove the heat from the fire. So you can see it's a pretty simple science all in all. The classes of extinguisher that you need to know are A, B, C, D, and K. Class A fire extinguishers are for ordinary combustibles, things like wood, paper, and cardboard. Class B fire extinguishers are for flammable liquids, like diesel, oil, gas, those types of things. Class C fire extinguishers are for energized electrical equipment. Class D fire extinguishers are for combustible metals. Those are things like sodium, magnesium, and potassium. Class K fire extinguishers are easy to remember because think of the K standing for kitchen. They're designed to put out oil fires in things like deep fryers. Now, one thing to know about fire extinguishers are some are specific to just one type of fuel. For example, it may be simply a type A extinguisher or a type K, but most can extinguish more than one type. For example, this is an ABC fire extinguisher. This is actually the most common out there. How it works is it uses a dry powder to smother the fire. Portable fire extinguishers are built to extinguish fires that are in the incipient phase. This is the phase that comes soon after ignition before the fire has really generated a lot of heat. A fire in this phase is roughly the size of an office trash can. Now, you don't want to extinguish fires that have gone to the next phase, which is the growth phase. In the growth phase, the fire starts to generate heat and grows rapidly. A fire extinguisher isn't designed to extinguish a fire that large. In fact, you're going to run out of chemical before you get that far along. One thing to note when making the decision whether to evacuate or fight the fire is that most fire extinguishers only have enough extinguishing agent to last about 30 seconds. In the event of a fire, always make the decision that your safety is your priority. Never put yourself in the position where the fire is blocking you from the exit, and only fight it if you feel comfortable and safe doing so. Now, to fight a fire using a fire extinguisher, remember the PASS method. That's P-A-S-S. Pull the pin, aim the nozzle, squeeze the trigger, and sweep at the base of the flames from side to side. Once the fire is out, it's not uncommon for the fire to reignite a few minutes later. So make sure that you're keeping watch until you're certain that it's out and done. Okay, so now you know the basics of fire extinguisher use. Make sure you go around your work area and check that you have the right fire extinguishers for the type of fuel available. Also, check the fire extinguishers to make sure that they're properly charged and ready to go in case they're ever needed.